Welcome to the deep dive.
Yeah.
Now, if you've spent any time, around golf, you know the obsession. It's always the clubhead, right? That shiny piece of tech.
Right.
But what if I told you that the real power center, this sort of invisible engine that most golfers, well, they completely overlook it.
Yeah.
It isn't the clubhead.
Yeah, that's absolutely right. It's kind of funny. People see the shaft as just, a stick connecting things.
Right.
When really it's this critical dynamic translator between your body's energy and what happens to the ball, its influence.
Well, it's way more profound than people think for consistency, efficiency, accuracy, all of it.
And that is exactly what we're digging into today. This deep dive is really anchored in some fascinating research by Henrik Jentsch. He did this meticulous analysis specifically on carbon composite shafts.
Mm-hmm. Groundbreaking stuff. Yeah, and it really shines a light on why understanding the shaft and maybe more importantly, getting custom fitted. It isn't just some luxury thing for tour pros. It's actually like fundamental for anyone who really wants to get better. So yeah, get ready to maybe rethink your clubs a bit.
Okay, so you call the shaft the true engine, this critical translator. That really turns the usual thinking on its head, doesn't it? I mean, I always just saw it as the connector. How does it actively work, like as this biomechanical bridge during the swing?
Well, it's anything but static, that's for sure. During, every single swing, that shaft is undergoing multiple pretty complex dynamic deformations.
Okay.
And these aren't just tiny wiggles. They're absolutely integral to how energy gets stored and then crucially transferred efficiently to the ball. Think of it less like a rigid stick, more like a sophisticated spring or a lever that's constantly reacting.
Dynamic deformations. Okay, that sounds like a lot's going on in that little shaft. Can you break down the different ways it moves?
Yeah.
Sure. So first you've got what we call lead-lag deflection. That's the shaft bending forwards and backwards, along the target line.
Yeah.
Mostly driven by the clubhead's inertia, just wanting to stay put.
Right.
Then there's toe up, toe down. That's the vertical bending influenced by gravity, your swing plane, that kind of thing.
Okay.
And really critically, there's torsional twist. Now, that's the rotation around the shaft's long axis, and that directly affects the club face angle when you hit the ball.
Wow.
And here's the kicker. These movements, they aren't mistakes or energy loss. They're designed in. A well-made shaft acts like a loaded spring, timed just right to store energy from your downswing, and then release it right at impact. That's where you get that extra pop, that ball speed, and control.
It's kind of wild to think of it like a coiled spring, that simple-looking stick. So, okay, if it's doing all that dynamic work, what materials handle that best? Why did we see that big shift from steel shafts to carbon composites?
Yeah, steel definitely had its day,
Yeah.
and it's still around, but carbon fiber composites, CFCs, they just offer superior properties. It really changed the game for shaft design.
How so?
Well, for starters, they have a much higher stiffness to weight ratio. So you get stability, but without all the extra weight. That's huge.
Lighter is faster, generally.
Yeah, exactly. But the real advantage with CFCs is the ability to precisely control the orientation of the carbon fibers. This gives you much better damping. It kills unwanted vibrations.
The feel aspect.
Right. And maybe most importantly, you can engineer different flex and torque profiles along the shaft's length. You can make one section stiffer, another softer, twist resistance, different here versus there.
So it's not just one uniform material property. It's layered and specifically designed.
Precisely. Henrik's research really highlights this. How the angle of the fibers, how the layers are stacked, it directly controls everything. Stiffness, flex, torque, vibration, everything. This level of control means manufacturers can, tailor a shaft very specifically to how someone swings, what kind of ball flight they want. You just couldn't do that with steel, not to this degree.
We always hear timing is everything in golf. Every little bit counts, right? How does the shaft tie into that precise timing, especially with terms like kick point and dynamic loft?
Yeah, those are definitely key. So the kick point, that's basically the main spot where the shaft bends during the downswing. And what's really interesting is where that point is directly influences your dynamic loft.
Dynamic loft. So not the number stamped on the club head, but the actual loft when you hit the ball.
Exactly. The loft presented to the ball at the moment of impact. It can be quite different from the static loft.
So how does changing the kick point affect that? What's the practical difference?
Well, generally speaking, a lower kick point closer to the club head tends to make the shaft tip kick upwards more through impact. That increases the dynamic loft, leading to a higher launch angle and typically more spin.
Okay, higher launch, more spin. Useful for getting the ball up, maybe?
Could be, yeah. Especially for players who need help launching it or want the ball to stop quicker on the green. Conversely, a higher kick point further up the shaft. That tends to result in a lower flight, less dynamic loft added, and usually less spin.
Huh, so maybe better for players who hit it too high or want more rollout.
Often, yes. High swing speed players sometimes prefer that to control trajectory and reduce spin. And Henrik's work really emphasizes that even tiny shifts in that kick point location significantly affect not just launch and spin, but also how efficiently energy is transferred. The whole goal is to make sure that stored energy snaps back right at the perfect moment for your swing to maximize ball speed and get the trajectory you need.
You know, it's funny. For years, I just figured, okay, stiff means stiff. Like you buy a stiff shaft, it's the same everywhere. But reading Henrik's research, wow, that idea just gets blown up. What did he actually find about consistency, or maybe the lack of it?
It is pretty startling, honestly. His testing, which was really rigorous, showed huge inconsistencies. Even between shafts that are supposed to be identical, same model, same stated flex.
How inconsistent are we talking?
We're talking stiffness variations up to, believe it or not, 34%. And frequency differences, which is another way to measure flex, differing by as much as 6%.
34%, that's enormous.
It is. He also found things like inconsistencies in the shaft walls, like seams or areas with too much resin. These can act like weak spots. And even the vibration damping wasn't always consistent around the shaft's circumference.
So a shaft labeled stiff might genuinely feel and play like a regular, or maybe even an X stiff, depending on which one you grab off the shelf. What causes that?
That's exactly right. It mostly comes down to manufacturing tolerances, tiny variations that are maybe acceptable on paper but add up. Things like how evenly the carbon fiber sheets are laid down, slight differences in curing, maybe minor flaws in assembly. The bottom line for the golfer is huge. Two shafts that look identical can perform and, importantly, feel completely different. Which, makes you wonder how you can expect consistency in your game if the tool itself isn't consistent.
Yeah, that definitely puts a dent in just buying off the rack and hoping for the best. So, okay, if standard isn't standard, what's the answer? This leads right into custom fitting, doesn't it? The power of getting a shaft matched to you. How does that actually transform things?
This is really where the science meets the individual. A custom fit shaft is engineered specifically to match your swing DNA. It's not just about swing speed.
What else then?
We're looking at your specific swing type. Are you smooth and gradual? Or do you have a really aggressive transition? What's your tempo like? How do you release the club? Even down to hand speed through impact. And beyond the mechanics, it's tuned to the feel you prefer, the control you need, and obviously the launch and spin numbers you're trying to achieve.
How do fitters even capture all that detailed info? Sounds like way more than just hitting balls into a net.
Oh, it is. We use modern tools now, things like eCoach 360 degrees or sophisticated motion capture systems. They really map out your unique swing signature, your biomechanics.
Okay.
And with that data, a good fitter can select a shaft with the precise combination of flex, torque, weight, length, and kick point that complements how you move. The outcome? It's usually a smoother feeling swing, much more efficient energy transfer into the ball.
And presumably better results.
Absolutely.
Yeah.
The benefits are usually pretty clear. Better distance, tighter dispersion, meaning less offline shots, and just an improved, more connected feel. And the beauty is, you often get this without needing to overhaul your swing. The custom shaft adapts to you, not the other way around.
It sounds like this research isn't just for us average golfers trying to shave off a few strokes. It seems like it gives coaches and fitters some really powerful tools too. How does this biomechanical view change things for them?
Yeah, connecting it back to the pros, Henrik's work gives coaches and fitters really valuable objective data. It shows clearly that you can directly link specific swing metrics, things they can measure like peak shaft deflection, how it lags and leads, the amount of twist.
Yeah.
You can link those directly to specific measurable shaft properties. So they can take swing data, maybe from something like eCoach 360 degrees, combine it with the material science of shafts.
And move beyond just how does that feel?
Exactly. They can move beyond the purely subjective. They can use real biomechanics to prescribe the optimal shaft for a player. It leads to much more data-driven, precise, and you'd have to assume, more effective fittings.
Okay, we have definitely covered a lot of ground, from how the shaft bends and twists like a spring to why carbon fiber is king, the whole kick point and dynamic loft thing, and maybe most shockingly, how inconsistent standard shafts can be.
And landing on the power of custom fitting.
Right. So I guess the big takeaway here is the shaft is so much more than just that tube connecting your hands to the club head. It really is that invisible engine you talked about right at the start.
It truly is. It's this high-performance interface between you, your body, your swing, and the golf ball.
And getting it custom fit, well, It just takes out so much desk work. It boosts consistency and maybe lets your actual swing perform its best. So, what does this all mean for you listening? If you're really serious about improving your golf game, maybe don't just obsess over the latest driver head. Think about investing in the shaft, getting it properly fitted. It really could be that custom key to unlocking potential you didn't even know you had.